Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another 2D Hack and Slash lesson. This is a lesson for a Pay What You Want course. If you're interested in supporting the course, there's going to be a link in the description where you can either donate via itch.io, or there's also a link to my Patreon or a link to my newest pixel art tileset course. So I just released a new pixel art tileset course a few days ago, and so there'll be a coupon code for that as well. So let's get started. In this lesson we're going to be adding a knockback state to our enemies. And this is important because currently if you run the game and you attack the enemy will continue attacking even when it's hit, and this feels really awkward. There's no sort of feedback for your attack. When you're a player, you want your attacks to really mean something, and if you hit the enemy and it deals damage, but there's no other outside visual feedback that you actually hit them, it feels really not that great. And so we're going to be adding a knockback state. So let's come into our night right here, and we're going to add a new state. Case knockback. And we'll add a new region. And inside of this region, we'll have, well, I have a break after the region. So we'll do a break outside here so we don't forget that. And pretty much what we need to do here is set a certain amount of knockback and set, well, first let's set our character's image. So we'll do state, let's see, set state sprite. And let's minimize this so we can see what our arguments are. We need a sprite, so S, night, hit stun. Then we need to set a speed. I think this one just has a 0 speed because it's a single image and a 0 image index. So let's double check that to make sure. Come into our night, hit stun. We'll need to set this origin too. So let's do, I think it's 24 and 48. Just like all the other ones. Okay. Yep, and so it is a single image. So then when we take damage, we need to be hit into our knockback state. So we can come into our hitbox right here. We hit a life form. Then we can set their state. Other.state equals knockback. Now our player doesn't have a knockback state right now. So what we should do is we should come into our player's step event. And I'm going to recommend adding a default case. Default. And just doing a show debug message state plus state does not exist. And then we'll do a break. So what does this do? This just takes, our state is a string, right? It's a string value. So because of that, we can put it inside of a message like this. So we can say state and then whatever state we are. So in this case, it would be knockback does not exist. So that's a really cool way that we can say, oops, we set a state that doesn't actually exist. So now we can come into our night and do the same thing. And our knight should enter the knockback state, but our player won't. So let's hit the knight. Oh, enters the knockback state. Perfect. Just kill it now. And let's run the game again. And let's get hit. Our player will get hit, and we should enter a, state knockback does not exist. It's telling us that state doesn't exist. And you could even have it change back to a default state if you wanted. So we could say state equals chase. So we'll just say, switch back to your default chase state if we enter a state that doesn't exist. For our player, we can do state equals move. Okay. Now let's add a little bit of actual knockback to our knight. So when we hit the other character, we can set their speed. Let's check some things here real quick. Our knight has a chase speed, and the knight moves using move and collide. Okay. So we're going to come into our knockback state. Let's see. I'm trying to figure out. I've been using my source example as like a base, but I've been changing some stuff to make it a little bit easier to follow. Because the original source code was made for a Ludum Dare game jam, and so I did a lot of stuff really quickly, and I cleaned up the source code a little bit, put some time into cleaning it up, but it was still done in a way that might not be easy for beginners to follow. So I've been kind of changing this code to make it more beginner friendly as we go along. And so because of that, there's potential for me to run into new situations that didn't come up in my original code. So we'll kind of have to watch out for that. So, but this one right here, we need to add some sort of knockback. And then we need to have that knockback value get reduced. So we could store this in a variable, and my gut feeling is that that's probably the way to do this. But our knight doesn't actually have a variable. The skeleton here doesn't have one either. So we never have to remember what our speed was in the last frame. But we're going to need to do that now. Now, we'll probably need to do this for all life forms. So we can come into the create event and we can add our variable in here. So we can just call this knockback speed. Like knockback speed equals, let's see. Knockback speed, we could set this to, well, we'll set this to 0 for now because we'll set it based on whatever the knockback value is. So let me close Steam here real quick. Exit Discord. Okay. And so we'll do, let's just try this. We'll go down this path, and if it doesn't work, we can change it. So our hitbox, we're setting their state to the knockback state. We'll set other dot knockback back. What am I doing wrong here? Knockback speed equals knockback. I think our hitbox has a default knockback value, so 1 right now. Okay. And this is going to be based on our, I think we'll want to have this based on the direction that we're hit from. Yeah, so let's test this first. We'll come into our knight, come into our knockback state. and we'll say knockback, we'll say move and collide, and then our X speed will be knock back speed, and then our Y speed will just be 0 because we don't need to move on the Y axis. So let's test this real quick and see how this works. Come over here, we hit him, and he's not moving at all. So our knockback speed, other dot knockback speed equals knockback. We're in the knockback state. And oops, I did it in default. That was silly, wasn't it? You guys probably saw that. You're like, oh my goodness, Benjamin, what on earth are you doing? Okay, we want it in the knockback state for sure. Let's try this again. There we go. So it's working. That's good. Now let's look at the very first issue with our knockback state, which is that if we come over here and then we poof, avoid him skill like and hit him that direction, obviously he goes the wrong way. So we don't want him to slide that way. That'd look weird. We also want him to slow down. So we're going to add a friction. And there's a couple ways that you can do friction. I'm going to do a method that uses the lerp function, which is a built-in function for linear interpolation. So we'll do knockback speed equals lerp knockback speed 0.1. Okay, now let me explain this line of code because I just wrote it out. So what this does is every single frame it sets our knockback speed equal to lerp, and this function, what it does is it takes our current value, this is our current value, and then it takes a target value, and then we can put in a percentage of the way there. So every frame will move 10% closer to 0. And that's what this is. This is 10% right here. 10% closer to 0. It moves this value 10% closer to 0. So this is our target, this is our current value, and this is the percentage of the way that we want to move there. Then we can add our exit case. We can say if knockback speed is less than or equal to, and then you get to decide whatever this value is. I'm just going to do less than 1. So if it's less than 1, then we'll set our knockback speed equal to 0, and we'll set our state equal to chase. So we'll switch back to our chase state. So now our knockback state has an exit case, right? So we can exit. And let's see how this looks. We'll hit him. There we go. And that looks pretty good. Now the problem with this, I just realized, is that this right here means no matter how fast they're moving, they're always going to be in the hit stun state for the same amount of time pretty much. And that might not be what we want, ideally. So that's a potential consequence of using the lerp function. And there are other ways that we could do this. We could create a script that moves towards 0, but no matter whether you're negative or positive, and then never passes it. That's possible too, and that's a common helper function in GameMaker. Many people call it like the approach script. So that's possible too. Let's try keeping this for now and seeing if we can change our attack knockback values. So in our create hitbox, we have a knockback value of 4. So let's do a knockback value of 2. So just a much lower speed on this one. And then our attack 2 will also do a knockback value of 2. And then our attack 3 will have a knockback value of 5. So we're going to bump up the knockback on the last attack and kind of send them flying. And let's just see how this works. So, and I'm not very good at getting the combo. I think it feels like it's a little bit different for this one. So it broke somewhere, didn't it? We can't get our 1, 2, 3 combo anymore. Huh. Let's check that out. I don't remember when that happened. So if input.attack, let's see, our attack 1 has input.attack. That looks good. Hit frame range. Huh. Maybe I'm just getting the timing wrong still. It feels like no, it definitely feels like we can't do our third attack. I don't remember when that happened. Interesting. I definitely feel like this isn't going to work though. I feel like a knockback value of 4 was better. We're going to need to fix that. But I'm not sure I want to do the debugging at the moment. So we're going to create a script for our knight's knockback so we can use more of an approach function instead of something like this. So we can say we'll create a script and we'll call this we have move and collide, so we can have apply friction like this. So in our apply friction, we'll just say well, let's name it. Let's give it a more general case use. We'll just use the approach. We'll make an approach function. So we're going to say if, well, we need to pass in some arguments. So we'll pass in current value, target value. We'll pass in a change amount, I guess, would be something. So var current value equals argument 0, var target value argument 1, and change amount argument 2. Then we'll say if our current value is less than our target value, then what do we want to do? So let's say our current value is 5 and our target value is 10. Then we're going to want to add the change amount, right? So we'll say current value plus equals change amount. And then we want to make sure that our current value never goes past the target value. So we'll say current value equals min current value target value. Okay, so the min function will give us the smallest, it will give us the smaller of these two. So let's say our current value is 10, well, let's say 11 after adding the change amount, and our target value is 10, then we don't want our current value to be past the target value, so we'll say current value equals the minimum of the two, and obviously target value is 10, so we're going to be the target value. Okay? And technically you can move this plus into here, like plus change amount, but I don't want to skip a lot of steps. So then, let's move this, else. We'll do the same thing, but if our target value is less than our current value. So we'll say current value minus equals change amount, and current value equals max current value target value. So this does the opposite. Since our current value is less than our target value, we're going to subtract the amount, and then once we get to it, we're going to do the maximum value. So if we're approaching 0 and our current value is -5, then it's going to return the target value of 0. Then at the end of all of this, we just do return current value. Okay, so we created an approach script. And approach scripts, they're very useful. Then instead of using lerp here, we can just use approach. And then we just have an amount that we're going to slow down. And so maybe we want to set this to 0.5. And this isn't a percentage anymore. This is how much we're going to slow down. So our speed will slow down in a linear fashion when we get hit by stuff. Yeah, we definitely want to have either a little bit slower on the friction here. So going lower on the friction seems like the wrong choice. Also, we no longer have to do if knockback speed is less than 1. We can just do equal to 0 now. Equal to 0. So let's keep this at 0.5 like it was, and then let's just add a bit more knockback. Where is our skeleton? Let's see. Okay. So hit 1, we had a knockback. Oops. We had a knockback of 4. Set that to 6. And then attack 2. Also had a knockback of 4. We'll set that to 6. Then attack 3. Even though we don't get a C attack 3, let's set it to like 8. And now I feel like having a slightly faster speed is good. But we should have a bit more friction on it. It's 2.75. Yeah, that feels like a pretty good amount of knockback. I don't know. The original game, it felt like I'd messed around with these values a little bit more and got them just right. So you guys might have to mess around with these more until you get something that works really good for your game. So let's try and debug this just a bit before we end this lecture. So you can learn some debugging skills. Let's see, we need to come into the skeleton. So we need to discover why we're not entering our third attack state. So we hit our attack 2 state right here, and this is where we set the attack to attack 3. Let's make sure. The very first thing to check is that this and this that they're spelled the same, they have the same casing. That's the very first thing I'd check. Then the next thing we want to check is we want to make sure that we're actually hitting this bit right here. So, and my guess is we're not. My guess is that our issue is in the if statement. So I'm going to click on this line and I'm going to hit F9. And that's, or you can click over here, I think. And what that does is create a breakpoint right here. Then we can run our game in debug mode. And we can try and enter. So look at that. What's happening is we are actually entering the attack 3 state. You can see that right here. Because I put a breakpoint right here and it actually paused on the game. So that means it's working. So now what we can do is we've confirmed that we actually hit that state. So let's come down to our attack 3. And let's confirm that we actually enter this bit of code right here. So we'll do a red thing there and make sure that we're making it to this point of the code. We'll run it in debug mode again. And let's see if we actually make it into attack 3. And we are. We're actually hitting the attack 3 state here. Where did my... Oh, I can't pan because we're in the debugger. So we're in the attack 3 state. So what's going on there? Let's check our knights. Our skeletons attack 3 sprite. We've got a stabbing motion, right? Lunge forward. So, why isn't this happening? Let's leave the debugger. Close all windows. Come back into our skeleton. So we're actually hitting the attack 3 state. That is interesting. I wonder if no, we know we're hitting the attack 3 state, so wonder if we're hitting this too soon for some reason. If for whatever reason we're hitting the animation end of our sprite. Nope. Do you guys see what I'm seeing though? State attack 3 does not exist. Oh my goodness, you guys, we forgot to put a break at the end of our state attack 3. Break. So our little default here was what was causing the issue, but at the same time, it gave us a nice, lovely little debug message that told us why. Basically, it was saying state attack 3 does not exist, which we know it exists up here, but what that means is we were hitting the default case. So we were running the attack 3 state, but then immediately running the default case afterwards because we didn't have an attack. We didn't have a break. So if you forget your break, what it does is run both of them. So yeah, there we go. There's some debugging for you. It's generally not super fancy. It's just kind of putting in breakpoints and trying to figure out whether or not you're making it to certain pieces of code until you find the place where you're not making it. Or in this case, making it to a piece of code that we didn't want. There we go. There we go. And I think that we should set these both to 4 again and see how that goes. So glad we have our 1, 2, 3 combo back. Feels much better. There we go. Okay. Now we've got a basic knockback in. And let's set these to 5. I want them to combo into each other. That's why I don't want there to be too much knockback on the first two. And then let's come into our knight again. We'll come into his knockback state. And we'll set this to like 6. So it's a little bit more than 5, but should still be pretty easy to combo. Now the last thing we need to fix is making sure that that direction goes the right way. See how it goes the wrong direction? So we need to make sure that the direction goes the right way on the attack. So the way that we can do this is by, in our skeleton, we could, I think we can multiply our knockback by our image X skill. Wait, are we passing in the... Oh, our hitbox has an image X skill, huh? So our hitbox should know... Our hitbox... Let's see, where's our create hitbox script? So our hitbox knows what its X skill is. And we can use that X skill information when we hit the enemy. So... when we collide with the life form, we're going to set other.knockback speed equal to knockback times image X scale, right? Because our hitbox already has the correct X scale. So then it should work in the opposite direction. Let's double check it. Yeah. It didn't immediately set the knight's X scale. Let's see. So we'll want to do that as well. So other dot image X scale equals we want it to be the opposite of our image X scale, right? So negative image X scale. So that sets the enemy's image X scale. It'll immediately set the enemy's image X scale to the opposite of our image X scale. It seemed like there's a little bit of a flicker there. Let's see if I can recreate that. Yeah. Do you see that? I feel like we need to give our enemy like a ton of health. So we can just hit it a bunch. Make sure this is all, we can test this a bunch. Stab him up against the wall. Doop. There is some sort of a flicker there, and that's interesting to me. Other dot image X scale. That's not the best way to do it, I guess. We can come into our knight, and maybe we just set it in the knockback state. Right here, we just say image X scale equals sine knockback speed. So we'll use the knockback speed. If it's negative, then this will return -1. If it's positive, this will return +1. And that I think will fix it. So, oh, except we need to do the opposite. So negative sign. There we go. Let's see how this works. Yeah. I really want that knockback amount to be lower. But I don't want him to leave the hit stun so quickly. It just feels like he leaves hit stun too quickly. So we'll do... Let's come back to like 3 on attack 1 and 3 on attack 2. And then we'll lower the approach script again to like 4. See how this works. I could fiddle with these values for days, so I might have to be a little careful here. That feels better. Let's set this to 3. And then set our, obviously for attack 3, we're going to want to set this to like 4. And then let's set this to, wait, do I want this to be more? Or do I want this to be less now? I don't know. I need to set up a better way to tweak these values, I think. Yeah, because that doesn't feel good. That feels better to me. Yeah, that actually feels pretty good. Okay, so let's talk about what I did. I set attack 1 has a knockback of 3, attack 2 has a knockback of 3, attack 4 has a knockback of, let's see. 1 is 3, 2 is 3, 3 is 4. And then my knight had friction. So let's make a variable, call it knockback friction of equal to 0.3. Knockback friction, we'll just paste this in here so we know exactly what that is. There we go. So I think this is probably a little bit longer of a lesson, but I feel like the debugging bit was helpful, and then it's helpful sometimes to just see how I solve a problem without having solved it already, because in some of my other videos I'll have the problem already solved. And this is already looking way better. We get a lot more feedback. The player gets more feedback while attacking the knight. Can kind of beat up on them for a while. So thank you guys so much for watching this lesson. I hope you enjoyed it and learned something from it, and I will talk to you guys later.